So problem number 1 on your review says that the following equation defines a function, and it says that f of x equals negative 6x minus 5. And then it says if you have an ordered pair, which is 5 comma p, and it's an ordered pair of the function, what is the value of p? Well, this 5 is an x value, and this p value is really a y or an f of x value. So if we plug in the 5 for all our x's, we should get out from the function the y, the f of x, which is also the p value. So let's plug it in. So we're going to get this equals negative 6 times 5 minus 5. Because what we did was we just plugged in f of 5, which means the 5 gets plugged in right there for the x value. So negative 6 times 5 is negative 30. That's this piece right here. Minus 5 more, so our answer is negative 35. The next thing on your review says to be able to identify a graph that represents a linear function of x and y, not as a linear function. So let's just talk about this for a second. So if I have a graph, a linear function goes straight like that, so that's an example of a linear function. This is an example of a linear function. I could also have a negative slope and go down as a linear function. I could even draw a vertical line. That's a linear function. But this one that I just drew, this one right here that I'm going to go over in red, this is not a function. It's a linear graph, but it fails when I draw my vertical line test. It fails my vertical line. So that one would, this one right here would not work. I could draw a horizontal line like this, and that would work just fine. However, things that are not linear, that are functions, that's a function, but it's not linear. And if we wanted to go further, if I drew a circle even, that's definitely not even a function. It's definitely not linear, but it fails the vertical line test. So make sure you know what is and is not a linear function. So I just want to review one more time. Positive slope lines, great. Negative slope lines, okay. Horizontal lines are great, but you cannot draw a vertical line because it's not a function. It fails the vertical line test. So this is not a function. So for problem number 3 on the review, it says, what is the slope of the graph line? So remember, to count slope, we're going to do rise over run. So what we need to do is we need to pick 2 points on this graph. And this graph is very nice. It gives you lots of little dots, but you can pick any 2. So if I pick this dot right here and this dot right there, I'm going to count how far I rise and then how far I run. So I rise -2, or I go down 2, and I run 1. So my rise was -2, and I went in the positive direction 1. So -2 divided by 1 is just -2. So the slope of this line is -2. And just to prove to you it doesn't matter which 2 dots you use, we can do any of these. So for this dot, to go from the top dot to the second dot, you go down 2 and over 1, down 2 over 1, down 2 over 1, down 2 over 1. Doesn't matter as long as you go between 2 of the dots on the line. So number 4 says that you have a line J that has a slope of 3, so m equals 3, and it goes through the point 2, 1, and says which is the one form of the equation for line J, and then it says the equation must be in y equals mx plus b form. So y equals mx plus b form, which we know as slope intercept form. So let's plug in what we know. Well, we have y equals my m, or my slope, is 3, x plus b. And we don't normally leave the b right here in the equation. So what I can do is I can plug in this 2 right here is my x, and this 1 right here is my y, so I can find b. So let's do that. So I'm going to get that 1 equals 3 times 2 plus b. 3 times 2 is 6, so 1 equals 6 plus b. Then you can minus the 6 and minus the 6. So now you know that -5 equals b, but that is not your answer because, again, you have to write the equation of the line. So if you look right here, we know that b is -5, and we also know that m is 3, so now I can actually write my equation. Y equals 3x plus a negative, or you could even just write -5. This is your correct answer. Number 5 says, what is the slope of the line that passes through -5, 8, and 7, -10? So what I'm going to do is I'm going to find the slope between these 2 points. So m, my slope, is equal to y2 minus y1 over x2 minus x1. And just a little review, remember these have to line up. So this x and y have to originally have been friends, and this x and y have to originally have been friends. So I'm going to call this pair right here my green pair. I'm going to call this pair right here my red pair, and I'm going to plug stuff in. So I have m equals, my y2 is -10, my y1 was 8, over, my x2 was 7, minus, this minus is from the equation right here, and then I have a -5. So -10 minus 8 is going to be -18. 7 minus a -5, you get to actually add these, becomes a 12, and then we can reduce this. 3 goes into both of these, so you can do actually 6 goes into both of these, so we can do -3 over 2, which is the most simplified version of our slope. Okay, so now we're on number 6 on your review, and it says that a farmer in Rio Grande Valley knows the number of green okra harvested varies directly with the plants grown. Last year, the farmer harvested 385 okra from 5 plants. So the number of plants is independent. So because of my 5 plants, I got out 385 okra. And so the farmer seeds 8 okra plants this year. How many okra can he expect to harvest? So the key word is that it varies directly. So you have y equals kx. This up here is my x and my y. So I'm going to plug those in. So now I'm going to get that 385 equals k times 5. And you have to divide the 5 over so that you can solve for k. So when you do that, you're going to get 77 equals k, which is our constant of variation. And so now we're going to use this k and write our new equation. Our equation now is y equals 77x. The question was, if the farmer plants 8 okra plants, how many okra can he expect to harvest? So that means this 8 gets plugged in right there for the x. So now I'm going to have y equals 77 times 8. And before we do this, we should think, I should get an answer bigger than 385, because when I had 5 plants, I got 385 okra. Well, now I have 8 plants, so I definitely should have more. And in fact, you do. When you multiply 77 times 8, you get your answer to be 616. So the farmer should expect to have 616 okra harvested from his 8 plants. Okay, number 7 says that student council is selling popcorn for a fundraiser. Each bag of popcorn earns them $3.75. The amount of money they earn is a function of the number of popcorn bags they sell. What is the domain and range? Well, first of all, let's talk about this. Domain, range. In this situation, what is domain? What is independent? Well, the domain is the number of bags sold, which makes the dependent the amount of money they raise, because depending on how many bags they sell gives you the amount of money they raise. So if I want to actually write the domain for the situation is 0, 1, because I can sell 0 bags or 1 bag or 2 bags or 3 bags, but I can't sell 2.5 bags or 3.5 bags, so it's really our natural numbers, 0, and all of our counting numbers. So then if we look at our range, well, if we sell no bags, we're going to have a 0 profit. If we sell 1 bag, we're going to make a profit of $3.75. If we sell 2 bags, we're going to make a profit of $7.50. If we sell 3 bags, we're going to make a profit of $11.25, and so on. So there is my domain and range. Okay, so number 8 says that if you have f of c equals 27, they want you to find -6 times f of c. Okay, well, you know that f of c is 27. Like, these are equivalent to each other. So if I want to find -6 times f of c, I have -6 times something. Well, this right here is my something. F of c is 27, so I'm just going to plug in my 27. And then you can just grab your calculator and type -6 times 27, and you're going to get your answer, which is -162. Number 9 says that if you want, that they charge to rent a car $28 per day, 28 per day, and then it says they charge 30 cents per mile. So Gilbert's total budget is that he has $345. He's going to rent a car for a short vacation, and he's going to be gone for 3 days. Wants to know the maximum number of miles he can drive without exceeding his budget. Well, he'll be gone for 3 days. I'm going to have 28 times my 3 for the 3 days that I'm gone, plus 0.3 times m, the number of miles I'm going to drive, which can be no more. It has to equal exactly my budget, 345. 28 times 3 is 84. So this thing right here is 84. So now I'm going to subtract 84 from both sides. And you're going to get 0.3 m equals 261. To get m by itself, you have to divide by 0.3 and divide by 0.3. So m equals, using my calculator, 870 miles. So as long as he drives no more than 870 miles, he won't break his budget. Number 10 is a proportion problem. So you have 3x plus 1 over -4 equals -2x minus 3 over 5. And you're going to cross multiply using what you guys call your butterfly method. So I'm going to cross multiply like this. So I'm now going to have -4 times -2x minus 3 is going to equal 5 times 3x plus 1. You should distribute to everything in the parentheses, so -4 times -2 is going to make a positive 8x. -4 times -3 is going to make a positive 12. Equals the 5 has to go into the 3 and the 1. 5 times 3 makes 15x. 5 times 1 is plus 5. And now you have to put the apples with the apples and the oranges with the oranges and put everything that's similar on the same side. So I'm going to move my 8x over. And I'm going to get that 12 equals 15x minus 8x's makes 7x's plus 5. And then I have to move my 5 over the other way. So 12 minus 5 is going to be 7 equals 7x. And if I copy this down up here, 7 equals 7x. The x is multiplying with 7, so to undo that, you divide by 7 on both sides. So now you have that x equals 1, and that is the answer to your proportion. So number 11 asks you what the domain and range are the coordinates below, and then it asks you, is the relation a function? So let's start with domain and range. X is the input, it's the domain. And f of x is like the y, which is the range. So to answer our question, I'm going to write sideways, but our domain is, and you have to put them in numerical order, so -5 is the smallest, then -1, then 9, and then 11. That's our domain. And our range, again in numerical order, is going to be -3 is the smallest, then -2, and then 0, and then 7. So there's our domain and range. And then the answer is the relation of function. For it to be a function, x cannot repeat, which means each x can only be sent to one place. So -1 is only sent to one place, 11 is only sent to one place, -5 is only sent to one place, and 9 is only sent to one place. So since none of the x's are sent to two places, thus none of the x's repeat, then yes, this relation is a function. Number 12 says which lines can be perpendicular to the line y equals -3 or to any other horizontal line. So I have y equals -3. So if I were to graph that, it would be right here. This is my horizontal line of y equals -3. To be perpendicular to it, I would have to draw a vertical line that's perpendicular. So any x equals any number, we'll call it a, any number a would be perpendicular to that line, and it thus would be perpendicular to any other horizontal line. So horizontal and vertical lines are perpendicular to each other. So an example answer would be x equals 1, because this could be 1 right here, or I could say x equals 2 and say that this is 1, 2, but any vertical line would be perpendicular to a horizontal line. The next part of number 12 said, which lines can be parallel to y equals -3 or any other horizontal line? So again, if I were to draw y equals -3, that's right here. Y equals -3. To be parallel, you would never touch. So to be parallel to this, I would need to draw another horizontal line. So example would be y equals -2, or y equals -1, or y equals 0, or y equals 1. Any of those are parallel because they would never, ever, ever touch. The next part of number 12 says, which lines can be perpendicular to x equals -3 or any other vertical line? So this is the opposite of the first part of 12. So if I were to graph the equation x equals -3, remember it's a vertical line, so 1, 2, 3, here's my vertical line, x equals -3. To be perpendicular to it, I would have to draw a horizontal line. So any horizontal line, y equals some number a, would be perpendicular to it. And then for the last part of 12, where it says what would be parallel, any other vertical line would be parallel to my black line of x equals -3. So all of these green lines I'm drawing are all parallel. So x equals any other number a besides -3 would be parallel. Number 13 says that we have the equation of line K is, and it tells us the equation, 2x minus 3y equals 9. And it says the other equation of line J is 6x minus 9y equals 10. And then it gives you some statements. It says which statements about these two lines are true. So let's put them in slope-intercept form to figure out the answer to this. So I'm going to move my 2x over, so I have -3y equals 9 minus 2x. Divide everything by -3, so I'm going to get y equals -3 plus, because a negative divided by a negative is a positive, 2 over 3x. On the other equation, I'm going to subtract my 6x and subtract my 6x. So I now have -9y equals 10 minus 6x. I'm going to divide by -9, divide by -9. So I now get that y equals 10. A negative divided by a negative is a positive, and 6 over 9 reduces to 2 over 3x. So I'm just going to list our options down. We have options A, B, C, and D. And so it wants to know which one of these are true. So it says, are the lines perpendicular? To be perpendicular, these slopes would have to be opposite and reciprocals. Well, these slopes are not opposite reciprocals. They're in fact the same. So option A is off the table. And then it says the equations have the same y-intercept. Well, the y-intercept for the first equation is -3, and the y-intercept for the second equation is 10, so it can't be B. And then it says, do the lines have the same x-intercept? Well, there's no way they have the same x-intercept, so it can't be C. But if you look right here, let's look at the slopes one more time. This slope is 2/3. And this slope is 2/3. So since the slopes are the same, they're parallel, and the answer is D. Okay, so number 14 gives you a table in their Amazon shipping rates for the maximum weight of packages. And it asks you if the pattern continues, if the shipping rate SOW amount is 10.55, what is the maximum weight of the package in pounds? So what we're going to do is we're going to need to figure out what the slope is, or how much it increases for every pound. So this is our table, and if you look, every time the increase here is that for every pound it increases 81 cents. So every time I go up by a pound, because over here the change is 1, every time I go up by a pound, it increases 81 cents. So I'm going to have y equals 0.81 times x, or times W, the number of pounds I have, and then I'm going to have plus 1.64. Because what happened is right here, this number, this is the flat rate to ship anything. Because it says right here that when it's 1 pound, it costs $2.45. So what I did was I took 2.45 minus the 0.81 that it would cost, and that's how I got 1.64. So if I were to ship something that didn't even weigh a pound, that weighed nothing, it cost $1.64, which is this, where I got this number from, which is my y-intercept, and then this is my slope. And then it says, what's the maximum weight I can have if my cost is $10.55, so that equals 0.81. X, or W, plus the 1.64. So I'm going to subtract the 1.64 from both sides. And I'm going to go on another page because I'm going to run out of room. And so what you get is 8.91 equals the 0.81 times x, and I'm going to divide both sides by 0.81. And so x will equal 11, which means the maximum weight that I could have is 11 pounds, which is your answer.